Suppose this oxygen is shared by two silicates. Then it will be like this. Sir, what is the name of this? Sir, what is the name of this? Two fellows are sharing one oxygen. The radical is for silicon. Should I write like this? SiO. This oxygen is shared with another silicon. O. Both are same. If one oxygen is shared, what is it called, sir? Pyrosilicate. If no corner is shared, orthosilicate. Sir, Si4O4 has 4 minus charges. What about this, sir? How many negative charges it will have? Whenever oxygen makes one bond, it will have negative charge. So actually it is Si2O7 6 minus. Can you see that really? The pyrosilicate has Si2O7 6 minus ions. Only one corner is shared. To neutralize the 6 negative charges, you can have, say, 2 aluminiums, Al2Si2O7. Aluminum pyrosilicate. You can have calcium pyrosilicate. You can have magnesium pyrosilicate. You can have so many.
Hello.
So what is this, sir? What is this? Orthosilicate. What is this, sir? What is this, please? Pyrosilicate, Si2O7 6 minus. Sir, next, if two corners are shared, only one is shared here, now two are shared. If two are shared, I can write like this, sir. 1, 2 are shared. If two are shared, it is like Si2O6 4 minus. Or simply SiO3 2 minus. If two corners are shared, what do you call such silicate ion, sir? What do you call this? Either it is chain silicate or it is a ring silicate. There are two variants. Let us make a ring silicate and see how it is. Sir, this is one silicate tetrahedra. Can you see? Okay, that's clear. There is one silicate tetrahedra. These are 4 oxygens. And in the center there is silicon. It is one silicate tetrahedra. Now 2 corners are shared. That's what I am saying. This is shared. Both are shared. Now here also 2 are shared. Here also 2 are shared. Silicon, 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 silicon. Sir, how many silicons it has, sir? How many it has? Si6. O's are how many? SiO3 2 minus. If there are 6 silicons, there will be 18 oxygens. What is the negative charge it will carry? What is the negative charge it carries, sir? SiO3 2 minus. Si6 O8, O18. How much minus? Nobody is answering. Sir, again you see, sir. Again you see, sir. Again you see this. SiO3, 2 minus. For every silicon, 2 negative charges, 3 oxygens. Here there are 6 silicons. To neutralize the 12 negative charges, you can have 3 beryllium ions and 2 aluminum ions. Because each beryllium is +2, each aluminum is +3. So I can say it as Be3, Al2, Si6O18. Or it can also be written as 3BeO dot Al2O3 dot 6SiO2. In the textbook, they wrote like this. This is called a green color stone called emerald. So emerald is a green color silicate where 2 corners are shared. It is called as the ring silicate. Emerald is a very costly gem. Are we seeing that? Sometimes where 2 corners are shared, it can be even like a chain. These are called chain silicates. Silicon, 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 oxygen, 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 oxygen. So notice that the SiO3 2 minus ions are there in ring silicates or in chain silicates. An example for ring silicate is popular green stone called as emerald. There can be many chain silicates. Sir, if 3 corners are shared, what is that called, sir? 3 corners. Now I am sharing 3 corners. 1, 2, 3. 3 are shared. If 3 are shared, it has a formula like Si2O5 2 minus. It is called as a sheet silicate. Because they exist like sheets.
One dot, sir. Sir, one dot.
What is your doubt? What is your doubt, sir? Hello. Let every doubt be answered. Any doubt I respect. Come on. Okay, no problem. I was wondering, sir, we are talking about rocks and stones. The rocks and stones are millions of variation in nature and they are fundamentally made with silicon and oxygen. They are called silicates. In the silicate, silicon is usually bound to 4. It is making 4 bonds. If it is making 4 bonds to 4 different oxygens, it is SiO4 4 minus ion. To neutralize the negative charges, we have positive ions, orthosilicate. If 2 silicons are sharing one common oxygen, one corner is shared, it is called as a pyrosilicate. If 2 corners are shared, it can be either a ring silicate or it can be a chain silicate. If these 3 corners are shared, then it is making a sheet silicate, and sheet silicates are like this. Sheet silicates, I am drawing a diagram of sheet silicate for you. Let us use black color. It is, our rule is how many corners are to be shared, sir? How many are to be shared? How many are to be shared?
3.
3. See, 1, 2. I am sharing third one. I am sharing third one. Like that you can extend. You can extend, right? Can you extend? I'm extending in the entire board. I can extend like this, right, sir? Here I will see. One can extend. Notice that in this giant structure which you are seeing, here there are silicons. Silicon, 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 silicon. Have you noticed that these are oxygens? So on. Sir, how many corners are shared, sir? How many are shared? I will write 1, this is shared, 2 shared, 3 shared. When 3 corners are shared, I am making a sheet silicate. It is a typical asbestos. Therefore,
Sir, please mute everyone.
see, this is the most ungraceful thing that I respect my students. I want them to have free access to talk and show, and they can't misuse this. I expect you to be disciplined and most respectful, sir. Okay, sir. Anyway, we are talking about the silicates. So there are so many types of silicates. If all the corners are shared, sir, you will be getting a polyhedra like this. It is called ordinary sand. And now, this is having a 3-dimensional network. And this is your typical stand. I can extend in any way. Now, I wanted you to notice. I wanted you to kindly notice. Okay. This is a silicon. If you carefully look at, every silicon has +4 charges, sir. Therefore, it is neutralized by negative charges of oxygen. As a whole, SiO2 has no charge. It is typical sand. It is called three-dimensional. It is called three-dimensional network solid. Okay. Okay. Now, the sand is SiO2. SiO2 is a three-dimensional network. There is no particular charge separation and it has very high melting point. Everybody knows. Now, I am saying that if this is sand, somehow the silicon is replaced by aluminum ions, then you will be having a problem. The silicon is +4, but aluminum is +3. As many aluminums are coming, as many plus one charges are missing. To neutralize the plus charges, because silicon is plus 4, aluminum is plus 3, another Na plus is needed or another K plus is needed. And now this type of silicate, where some of the silicons are replaced by aluminum, is further requiring sodium or potassium ions to get something called sodium aluminosilicate or potassium aluminosilicate. They are called as zeolites. They are called as zeolites. The zeolites are wonderful materials in petrochemical industry. Generally, long chain hydrocarbons are bad fuels, and the method of breaking a long chain into simple chains is called cracking. For cracking of petrol, zeolites are used as catalysts. Also, there is a particular zeolite called ZSM5 that can convert your alcohol into petrol or gasoline. In America, the petrol is called gas or gasoline. So alcohol is converted into gas by using ZSM5. Most of them are precious stones and most of them are very important minerals, and silicate chemistry, it is so vast. This is itself a subject called geology, rock science. So I can't go more details than that. At this point, we are going to now, I also discussed with you silicones. Do you remember silicones, sir? Hello? Yeah, I think you remember silicones. I don't again go there, but I make a quick review of that in your textbook. Okay. Now we are looking at silicones. In the available time, we have to do a lot of work indeed. Ladies and gentlemen, here we go. We talked about silicon dioxide. We agreed upon that 95% of the earth crust is made up of silicates. SiO2 can be like quartz cristobalite tridiamide crystalline form. It can be like agate, onyx, jasper, fine powder form. Silicon dioxide is a covalent three-dimensional network solid like this. Sand is acidic but not soluble in water. It reacts with NaOH to give sodium silicate. The only acid that can attack sand is HF. Quartz acid is piezoelectric. If you apply pressure, it gives electric current. Such crystals are used to generate light when the small children are walking using their shoes. The shoe on compression gives light, means it is containing quartz crystals. Silicones are a group of organosilicon polymers. Organosilicon polymer means polymer is a chained molecule, very long chains and cross-linked chains it will have. And its general formula is R2SiO. R2 means alkyl groups. If you have R2CO, it is called ketone. Nail polish remover is a ketone. R is representing carbon hydrogen, hydrocarbon chain. So the silicones have a formula R2SiO like ketones, but ketones are simple molecules, so silicones are polymeric. Silicones are made in this way. You take something called methyl chloride, CH3Cl. You can also take any other alkyl chloride, ethyl chloride, propyl chloride, so on. Generally, CH3Cl type of molecules are called RCl. Two RCls react with Si in place of copper to get R2SiCl2. R2SiCl2 when treated with water, Cl is replaced by OH. This compound, which has two OH groups on either side of silicon, can continuously combine with itself. By losing water, it can give a polymer called silicone. If you want to close the chain, normally it grows without control. If you want to close the chain, you should add CH3 taken thrice SiCl, trimethyl chlorosilane. If you are using this trimethyl chlorosilane in one end, there the reaction closes. You can also take another compound like trichlorometh. He has not drawn. In this structure, you see, if you take instead of trimethyl hydroxysilane, you take trichloro, only one methyl. You see, you take this. I am showing this. Yeah. If you take, there it is. Yes. This compound, MESiCl3, it is called methyl trichlorosilane. If you take methyl trichlorosilane, this on hydrolysis gives a branched chain polymer. It will have chains in the horizontal way, vertical way also. So that is a typical IIT main question. To close the chain, one side you should use trimethyl chlorosilane. If you want to have a branched silane, you should take trichloromethylsilane. If the Cls are 3, 1 methyl, that on hydrolysis gives branched silane. If the chlorines are 2 and methyls are 2, it will give linear silicone. If only 1 chlorine and methyls are 3, then that will close the reaction. So this is the variation. Main important point is silicones are very, very useful. They have wide applications used in sealants, greases, electrical insulators, waterproofing of fabrics, and being biocompatible, they are also used in surgical and cosmetic plants. We are expecting a question on silicones and silanes, so I spoke about them in detail again and again. All other things are very simple in this lesson. Very, very simple in this lesson. One can read them without any trouble. Okay. They are very simple. So let's not worry about them. We are quickly scanning them. Now, sir, in this lesson, carbon dioxide. About carbon dioxide, you are studying right from your 3rd class. Carbon dioxide is obtained by burning of carbon. Carbon dioxide is absorbed by plants to make photosynthesis. Carbon dioxide is released when the burning petrol, and carbon dioxide is generated when limestone is heated. So on, we are studying. Carbon dioxide is a colorless gas. It is a odorless gas. It is a tasteless gas. It is soluble in water. When it dissolves in water, you get H2CO3. The soda which you buy in the market, Whistler soda, it is made with carbon dioxide dissolved in water. When carbon dioxide dissolves in water, you get H2CO3 known as carbonic acid. Carbonic acid can give H plus ion, so it is an acid. The H2CO3 carbonic acid, NaHCO3 sodium bicarbonate, which is known as baking soda. The buffer system helps in maintaining pH 7.26 to 7.42. pH is a scale that measures the acidic nature. If pH is below 7, that is acid. pH is above 7, it is base. Our human blood is a base. Its pH is between 7.26 to 7.42. If our blood pH changes more than this, we will die. If a snake bites us, snake will inject acid into our blood. Our blood pH will drop below 7.26. So immediately we will die. Our blood pH, if it goes up or down, we will die. What is blood? Why its pH is 7? All this you study in physical chemistry once again. I will not go to the details at this point of time. Notice that the carbonic acid combines with alkalis like NaOH to form sodium carbonate like carbonates. So it is important to notice. See, if somebody is joining in between, it is a problem. I have to come back and again I have to work. So, sir. So about carbon dioxide, you studied a lot. If you bubble carbon dioxide into lime water becomes milky because of the formation of CaCO3. If you continuously bubble CO2, again the CaCO3 combines with CO2 and water to give bicarbonate, solution becomes again clear. The CO2 is there in air by only 0.03%. It is very much essential for photosynthesis. If there is excess of carbon dioxide due to burning of fuels, the globe becomes hotter and hotter. The phenomena where globe is becoming hotter and hotter is called greenhouse effect. See, when I came to Hyderabad some 35 years back, Hyderabad was very cool and very pleasant and wonderful. There were so many grape and wine gardens. You can buy grapes like anything. Beautiful Hyderabad. Now it became very thickly populated. No grape yards, no grapes you can buy around. And I don't know, it became filthy and overpopulated and it is not comfortable. and it is no more cool. All this is called greenhouse effect. Carbon dioxide can be obtained as a solid. The solid carbon dioxide is called dry ice. If you buy dry ice, that is solid carbon dioxide, and put in water, it gives intense fumes. In cinemas, to generate clouds, they buy dry ice and put in water. Mainly carbon dioxide is used to make carbonated drinks like your Thumbs Up, Coca-Cola, whatever. A lot of carbon dioxide used nowadays to manufacture urea. Urea is a fertilizer. There is a concept called hybridization in chemical bond that explains how bonds are formed. Normally, a bond is formed by sharing of electron pair between two atoms. But the electron pair is formed by one electron from one atom, one electron from other atom. But these electrons are there in orbitals. So, one atom having an orbital with one electron, another atom having another orbital with one electron should sit one over the other. When they are sitting like that, we call it as overlap. The overlap of orbitals can make a bond. But ordinary orbitals are not so good to overlap. Therefore, the orbitals of atom will undergo mixing called hybridization. So, what type of hybridization an atom undergoes decides what shape of molecule I get. Also, how many bonds, sigma bonds an atom can make is decided by type of hybridization. If you have sp hybridization, it means one s orbital, one p orbitals are mixing to get sp hybrid orbitals. Because one s, one p, two orbitals are combining, you get two hybrid orbitals. They are called sp hybrid orbitals. These two orbitals are separated by 180 degrees. That makes the central atom to make two bonds separated by 180 degrees. Such two bonds separated by 180 degrees gives a linear molecule. Carbon dioxide is a linear molecule. You will be wondering, sir, what are the other hybridizations? If one s orbital and two p orbitals mix up, I get sp2 hybrid orbitals. The number of sp2 hybrid orbitals would be 3. The 3 hybrid orbitals will be as far away as possible by 120 degrees. If 3 lines are separated by 120 degrees, then we get something like trigonal planar molecule. BF3 is a trigonal planar. In carbon dioxide, carbon is using sp hybrid orbitals, so it is a linear molecule. In CO2, both CO bonds have equal length, 115 picometers. Sometimes the CO2, central CO2, the lone pair can come onto the carbon and oxygen, making a triple bond like. Because the terminal oxygen wants to take the pi electron all by itself to selfishness. The oxygen which is taking the 2 electrons is getting minus charge. The oxygen which is giving the 2 electron as bond is getting plus charge. This can happen this side and that side. This type of gimmick of electrons flow in a molecule is called a resonance. Due to resonance, molecules get extra stability. So this is a quick story on carbon dioxide. Carbon makes another oxide called carbon monoxide. The carbon monoxide is formed due to incomplete combustion of carbon. When you pass steam over red hot carbon, steam means H2O, carbon means C. H2O plus C due to heating can give carbon monoxide. There are many questions how carbon monoxide is generated. There is something called formic acid. When formic acid reacts with sulfuric acid, you get carbon monoxide. When oxalic acid reacts with sulfuric acid, you get carbon monoxide and carbon dioxide. So carbon monoxide is a strange gas not soluble in water. You by mistake, if you inhale carbon monoxide, you get headache, nausea, vomitings, giddiness, and death. The level of carbon monoxide increases, the danger increases. Up to 9 milligrams of CO in 1 kg air, called 9 ppm, is allowed. If it is more than 9 ppm, CO is poison. If you come to Amirpet once and go, you get headache. Why? In Amirpet, vehicular traffic is so heavy that so much pollution is created by burning petrol. So carbon monoxide level in Amirpet is heavy. So people who visit Amirpet once, they get immediately headache. But people who are staying in Amirpet, they adapted themselves to that. So they don't feel any difference. I would say carbon monoxide is toxic. Water gas is a mixture of CO and H2. Producer gas is a mixture of CO, H2 and N2. Notice that producer gas and water gas are very important industrial fuels. And I am saying carbon monoxide is a neutral gas. Carbon monoxide can give electrons to others very easily, so it is called powerful reducing agent. If you take any metal oxide react with CO, CO will become CO2, metal oxide would become metal. For example, iron oxide on heating with CO gives iron and carbon dioxide. So this fellow, which is removing oxygen from oxides of metal, is called a reducing agent. It is used in extracting metals. Two examples are cited in the book where iron oxide is becoming iron, zinc oxide is becoming zinc. Very, very interestingly, carbon monoxide can combine with so many metals to give compounds known as metal carbonyls. When you inhale carbon monoxide, your blood will make a carboxyhemoglobin. The carboxyhemoglobin is formed due to bond formation between iron of blood and carbon monoxide. The carboxyhemoglobin cannot carry oxygen, so we will die if we inhale carbon monoxide. The carboxyhemoglobin is very stable. It is not interested to lose CO and take oxygen again. No. So the carboxyhemoglobin formation means death. The carbon monoxide is a very important chemical industrially because it is used in the manufacture of methyl alcohol. In carbon monoxide also carbon is sp hybridized. This is a quick note on carbon monoxide, carbon dioxide, silicon dioxide, silicones, silicates. Are we very clear about these four aspects, sir? Tomorrow we try to have a glimpse on what is Buckminster fullerene, what is the difference between graphite and diamond, and some other aspects. Tomorrow is the last day to conclude this chapter. I will upload so many questions in YouTube for you. Please watch the YouTube as an additional input in order to learn the lesson. Hello, are you there? I will now enable you to speak. I am enabling you to speak. You can speak. Hello?
Yes, sir.
Yes, sir, you speak. What is your idea?
Sir, you are going to upload the videos on YouTube, sir.
I could not get you, sir. Say, come again.
Sir, you are going to upload the videos on YouTube.
I am?
Are you going to upload the videos on YouTube, sir?
I am planning to upload some one or two more videos in YouTube. You tell me what topics you want. Anything you want, you ask me. Or
Regarding
you can
this
always
chapter
ask
only.
your doubts. Hello. You can always
Yes,
ask
sir.
your doubts through WhatsApp anytime.
Okay, sir.
And I am to the extent answering their doubts immediately and making YouTubes as per your requirement. Okay?
Okay, sir. Thank you.
At the end of the day, sir, our goal is you should be able to do chemistry rapidly. Okay?
Yes, sir.
Read
Okay.
the NCERT book.
Last time
Rejoin again.
Excuse me?
You want to rejoin again?
No rejoining. This is enough. We can't do more than this. Okay? So I wish you good luck. We
class
are
timings
closing
are
this session.
from
for
11,
today.
sir. Now onwards.
What did you say?
Class timing, sir.
Class timings, sir. Tomorrow's class timings. 7:45, 11.
No, your timings are this permanent. Always 11.
Okay, sir. Thanks.
So that morning you are feeling difficult to get up. Therefore, to your convenience, we have changed the time. Okay?
Okay, sir.
So tomorrow we will meet. Tomorrow is the last day for this topic. All the best.